with Auntie Taiwo. So today we'll be going to naming of organic compounds. Yes, I know a lot of students, they don't like the organic aspect of chemistry. That is difficult. It's actually not difficult. You just have to put your mind to it. So if you have not subscribed, you are very, very wrong. So please kindly click on the subscription button and let's go to the class. So today we'll be talking about naming of organic compounds. Organic compounds are basically compounds of what? Carbon and hydrogen. Yes, and carbon is very unique in its own way. It's able to form long chain of carbon to carbon bonds that we call catenation. Then 4 bonds surround each of the carbon atom. So either you have double bond, maybe you have a double bond, so you just have to make sure, or you have a triple bond, you just have to make sure that the bond surrounding each of the carbon atom is no more than 4 and is not less than 4. Okay, so I'll be naming some organic family. Okay, I will start with the first 4. We have the alkane family. We have the alkene. We have the alkyne. And we have the alkanol. Yes. So now for your alkane, you have the general formulas to be CnH2n plus 2. Yes. Then the alkene CnH2n. Then the alkyne CnH2n minus 2. Then you have the alcohol to be ROH, which the R stands for the alkyl group. The alkyl group, which is represented as CnH2n plus 1. Okay, so this is the way in which they are being represented. Okay, so now, and we have them in 1 carbon down. You have 1 carbon structure, 2, 3, like that. Like starting with the first family alkane, the first member is what? Methane, which is CH4. Then you have ethane, propane, butane, pentane, ethane, heptane, octane, nonane, and decane. Just like the way you have your polygons, your pentagons. Yes, it's for your nonagons. It just follow that trend. Okay. Now coming to the naming of organic compounds. Yes, you need to put certain things into consideration. The first thing you are expected to do or to know is the family in which an organic compound belongs to. Now for the first 3, you have alkane to be single bond, you have them to be single bond. Alkane, you have them to be double bond. And alkyne, you have them to be what? Triple bond. So anytime you cite single bonds in between the carbon atoms, you know that, oh, this one is alkane. Whenever you cite double bond, you should know that it's alkane. And whenever you cite triple bond, it belongs to the alkyne group. Yes. Then the alkanol is what we also call the alcohol family. Anytime you cite the OH group, which is the hydroxy group, then alkanol should come to your mind. Okay, so now I'm going to put a structure. Yes, naming of organic compounds. The first thing you need to know is the family in which the organic compound belongs to. Then after that, you find the longest chain. Now the longest chain can be straight or branched. It depends on how the structure is being written. Then another thing again is this: you can also have what we call substituents on the structure. You can have some attachments on the structure. You can have the alkyl group attached to the structure. You can also have the halogens, yes, like your chlorine, your bromine, your halogens, they can be attached to some of these structures. So then you find a way to name them. And in that regard, the naming has to be what? In alphabetical order. Then again, when you have maybe the double bond or the triple bond, you name in such a way that the numbering, because we are going to do what we call numbering. Yes, especially when you have the double or the triple bond. So you do what we call numbering, and you number in such a way that the functional group, which is the double bond or the triple bond, have a lower number. Yes, it has a lower number. So I'm going to draw some structures. Now there are some structures that they will give you in expressed form or in a collapsed form. So I'm going to write a collapsed structure now, then I will now express it for us to see. Okay, so if you have something like this, CH3, CH2, okay, 3, I have another CH2, then maybe I have another CH3, then maybe CH2, then I have another CH3 closing up. So I'm going to express it now for us to see clearly. Okay, let's change this one to 2. Okay, so that we will not have a very long chain. Okay, so CH3, C, then I have my hydrogen, 3 of them. You can see the way I'm expressing them now. Then CH2, CH2, I have how many? 2. CH2, I have another one. Okay, I have another CH2, CH2. Yes, I have another CH2. Then I have CH. Then with the CH, I have CH3. Okay, then I have another what again? I have CH2 2 times. Then I have another CH3 to close up the chain. Okay, I have a pretty long chain here. So like I said, that we are going to see the longest chain. Yes. So I'm going to count how many carbon atoms do I have? 1, 2, 3, 4, 5, 6, 7, 8. This is the longest chain because, and I told you, it can be straight and it can be branched. But even if I branch, it's not going to be the longest. I can do 1, 2, 3, 4, 5. It's not the longest. 1, 2, 3, 4, 5, 6. It's not the longest. So this straight is the longest. Okay, so I will now do what we call the numbering. Yes, I will do what we call the numbering. Okay, if I number this way, 1, 2, 3, 4, 5. That means my methyl diazole will be on carbon 5, which is wrong. I have to number in such a way that at least I have a lower number. So 1, 2, 3. Okay, so let me do my numbering this way. 1, 2, 3, 4, 5, 6, 7, 8. So on carbon 4, I have the methyl. Yes, the methyl is the alkyl group. This is it here. Yes. And the first member is methyl, just like the way you have methane, ethane, like that. It has just 1 carbon atom with what? 3 hydrogen atoms. Okay, so now let's name. So that, and this is the only substituent that we have on the structure. So I have what? 4-methyl. Then what is the parent name? 1, 2. We have 8 carbon atom. 4-methyl octane. Yes, 4-methyl octane. Yeah, perfect. So now I'm going to do another structure that have the double bond, and you will see how the naming is going to take place, because we're actually going to give preference to the position of the double bond. So we have something like this. I'll just carve out a structure here. Okay. Let us do here. So here I can put my bromine. Here too, let me put, okay, this one is up to 4 bonds. Here, let me put another bromine. Okay. Then here, let me put methyl CH3. Okay, just like that. So that we'll just see how we can go about the naming. And I have emphasized that your carbon should be surrounded with only 4 bonds. So here I already have 4. 1, 2, 3, 4. Okay, so here I'll just put another hydrogen to make this one 1, 2, 3, 1, 2, 3, 4. Yes, so this is perfect. Okay, now let's try and name this structure. Now the first thing I'm going to do is to get the functional group. Here I told us once you cite a double bond, yes, you know that it is what? Alkane. Yes, that's the first thing to do. So I know that this is an alkane family with the presence of the double bond. Then the next thing I'm going to do right away now is what? To count, to know my longest chain. So my longest chain is still going to be like the straight one, like we did for the last one. 1, 2, 3, 4, 5, 6. Okay, so I have 6 carbon atoms. Okay, so now let us check what are the things that we have on the structure. Now I'm going to number. Yes, I'm going to number my carbon atoms. Now it will be wrong for me to number from this side, because if I number from this side, my double bond is going to have a higher number. So if I number from this side, the double bond position will be lower. So I have 1, 2, 3, 4, 5, 6. Yes. So on carbon, between carbon 2 and 3, I have my double bond positioned. So I'm going to take number 2 as the carbon that is carrying the double bond. Okay, so what else am I going to look out for? I'm going to check what other substances, what other things do I have on the structure. I have bromine here, I have bromine here. So I have on carbon 3, 4 bromo. So I'm going to say 3, 4 dibromo, because I have 2 of the bromine atom. Then again on carbon 5, I have what? Methyl. Okay, so these are the things that I have. So now how are we going to write? Now we are going to follow alphabetical order here. I'll be writing for the bromine first. So I have what? 3, 4 dibromo. Okay, 3, 4 dibromo. Okay, I have on carbon 5, I have 5 methyl. Now I will now have on carbon 2 is the double bond, X, 2 in. I cannot just write Xn. No, I must give preference, I must give honor to the position of the what? Double bond. So that is why I have X2 in. So I have 3, 4 dibromo, 5 methyl, X2 in. So we have been able to do naming for what? For the alkane and the alkyne. So when next to me, we'll be going to alkyne and the alkane. So please solve different questions there. And there's something we call isomerism as well. Isomerism is a situation whereby you have the same molecular formula but different structural formula. So